Okay, this is problem 5 in section 9.3. You are basically given 3 sides here. So you would be using the law of cosines. If you're given a triangle with 3 sides, you're trying to find angles. You can decide which angle you want to find first. Sometimes it's just easiest to do C because that's the one that you have the little formula for here. Cosine C is equal to A squared plus B squared minus C squared all over 2AB. Of course, the colored ones are the ones that I found. There is not going to be true triangles because what you have is side, 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 and it does not produce but one triangle. Okay, that's the basic formula. You go start plugging in. It would be 7 squared plus 10 squared minus 11 squared divided by 2 times 7 times 10. That's what you've plugged in. In order to find C, you're going to have to end up using the inverse cosine to get C by itself. So it's like you take the inverse of both sides, and that cancels, and you're left with C. When you plug this into the calculator, you end up with 78.46 blah, blah, blah. Well, if you rounded it to one decimal place, it would be 78.5. All right. Then you found angle C. Now, we need to go find one of the other two angles. I'm finding B, and then we'll do A last. Sine of B is to B as sine of C is to C. You can use law of sines, or you could back up and go back with the law of cosines also. But using law of sines, sine B is to 10 as sine of the 78.5 that we just found is to 11. You've substituted in here. You substituted for B and you substitute for C and you substitute for side C. And side C is actually 11. You make those corrections. Okay, I think that's right. That's what we've got in. We cross multiply, get that for the top, and then we had to divide by the 11 to get sine B by itself. We had to take the inverse to get rid of the sign that's with the B, so B is by itself. This is the calculation, so when we round this to one decimal place, we get 63.0. I've also done it using the law of cosines if you wanted to see it. It's plugged in here, just like we did before. When we round it, we still get the 63 degrees. There is a slight difference after you get a good ways away from the decimal. There's a variation there. Technically, this is the more accurate because we did some rounding in our angle that we used in the law of sines. But notice that you get the same thing as far as plugging it in is going to be concerned. And I've kind of stated that information here if you wanted to read it in a little bit more detail. Now, we're going to find angle C because the sum of the three angles equals 180. So we take angle B and angle C. We found both of them. That's what they are. And we subtract that sum from 180. And we get the 38.5. And that is angle A. And you can go up and see that we have found all three angles. That's the three angles, and below is the work on how I found those angles.